Hello and welcome to the next episode of CyberPotato, where I'll be teaching you about functions in JS. Okay, so we already talked about functions basics in the last episode, but now it's time to dive deeper into it. So here I have an example array of actors' names. In the last episode you saw me writing function like, for example, this: get me string length, and then I specify an argument, some random string, and we can do something like this. For example, get me string length actors index 0. Let's log it. Okay, and we get 14 here. But starting with ES6, the newest version of JavaScript language, ES stands of course for ECMAScript, we can write our functions using arrow function location, and it looks like this. We say const because we can assign function to a variable, as you already know. We do arrow, braces, and these two notations are basically the same. But what is cool about arrow function is when the body of the function is just one line, just some simple return statement with some simple calculation, I can shorten it to look like this. Get me string length short. Let's call it like this. Okay, so I can do an immediate return after arrow functions. And now this and this and this function do exactly the same. So this notation is very popular because we often tend to compose short function to solve more complicated problem. And then you can just write a bunch of these one-liners and compose them to achieve a much bigger result. And of course, just to prove to you that it still works, I hope, I can, it's short, I can do this. Okay, you should get, yeah, it's the same. Okay. What else? Okay. Another problem is something called carrying the function. So I can write a simple function to multiply two numbers, and it would look like this. And I will, of course, call it by specifying both arguments 10 and 20. Okay, still working good. But there's this approach to writing functions that is called currying, where you can do partial application, meaning you can even if the function takes 2 or more arguments, you can specify one argument at a time to create a new function based on the function that is carried. So to provide you with an example, I can do multiply carry, I don't know, you tell me. And it looks like this. X times y, okay? And this notation, although looks strange, it's exactly the same like this. Function multiply curry takes x, returns function takes y, function, yep, return x times y. And those two notations are the same, so it's a function that takes one argument and returns a function that takes another argument, and then in the end we're doing the calculation. Okay, so how to actually call that function? Curry long, let's call it. Multiply curry times, let's say 2 times 4, okay? That's it. So I specify first argument, and this call will return a function immediately. So then I specify another argument, and these two are calculated in the end. To prove you how it's working, I could write something like this. Multiply times 5 is multiply curry. Okay, so this returns a function that will multiply any other argument specified to multiply times 5. Okay, so I can just call console log multiply times 5 20, and then console log multiply times 5 100, and so on and so forth. So this call, when I specify only one argument, where my caret function is expecting 2, is creating another function that I can reuse to specify many different arguments. And it's actually really good because you don't repeat yourself, you reuse the function that you've already created. Okay? What else? Okay. So the first thing we have is arrow function. And you'll see me using arrow functions most of the time. Then we have currying that you'll see me use from time to time. But a few episodes ago I was talking to you about loops, and that I don't really fancy the for on while loop because I believe there are better solutions. And now it's time to actually present those. So let's do reduce function. Okay. So I have my actors here, and reduce is a function, that method actually, that lives on an array, that lets you take every single argument, every single entry from that array, and reduce those or sum those up to 1. Okay, for example, if I have numbers array, okay, let's do like 0, 10, 23, 12, no matter really. Okay, and I would like easily to calculate the sum of those. I could write it using for function. I could do for let I equal 0, I less than numbers length, and I incremented. I could do let sum equals 0, sum equals numbers index from A. Yep, that should work, I assume. Yep, it's there. Just add sum from 4. Okay, that's it. But as I mentioned many times already, I don't like for or while loops. So what's the better way? We can use the reduce function, and I encourage you to, let's just close others. I encourage you to go to MDN and search for reduce, because yeah, MDN documentation is real good regarding. Okay, so yeah, reduce. I can just, instead of doing it imperatively, I can just do it declaratively, telling what I would like to achieve for each and single entry from array. So I can write numbers, reduce, and here we have the signature of the function. We have to provide a function to it, specifying how we would like to sum or calculate for each and single entry of the array, and then we have to specify the starting point for the reduction calculation. Okay, so let's start with the last argument. I would like my calculation to start from 0, because, well, that would give me an actual sum starting from 0. Okay, and then the function. So I tend to name the first argument accumulator, ACC, and then we can specify next. Okay, so for the time being, let's just log those two. I'll say accumulator is, and then next entry from the array is. Okay, and what we've got here is some has already been declared. Some reduced. Okay, let's see. Accumulator is 0, then the first entry is 0, then 10, 23, 12. So each and single entry from my array is here, so we're actually looping through the array, and then accumulator is 0, and then it's undefined. Okay, it's undefined in the next steps of our array, because we actually have to return something in our function. Okay, this arrow function starts here, ends here. Okay, let's see now. Better, we always have 0, but I would like to have sum calculated or each and single step of the loop. So I will do ACC plus next. Okay. Should I? Yeah, I should log it. sum after reduce. So this is sum reduced. Let me just, yeah, okay. Sorry. So they're the same. So this is called reduce because it takes your array and it reduces it into a single value. Okay? So that's actually nice. So I have a starting point as the second argument. I have arrow function here that specifies what to do on each and single step, and I don't have to try to track the index. I could, of course, rewrite it to reduce function and say that this is, let's reduce callback function is this, and let's say that starting point is 0, and then I can write this like this. Okay, same. I just tend to use the anonymous function and specify it in one line, so you don't have to actually break your train of thought, just read it. Okay, so here's the function body, and this is a starting point. I don't have to wander around my files and check for the starting point and callback function and where was it defined. So yeah, let's go back to that. You'll see me mostly using this kind of notation. Okay, so that's good. But let's think about another example where, for example, I would like to perform some operation on each and single entry in my array and return a new array. So I have an array of something and I want to transform it to another array of something. So it's A, and let's say to transform it to B, B. So transforming one array into another array. Let's do this using reduce. So I will call this function map, okay? And this function will take array as first argument and callback function as second argument. And what I'm gonna do is call array reduce, okay, with ACC and next. So it's this and this. And what I'm gonna do is say, oh, let's say that my entry point is empty array because I still want to preserve array to array transformation. Here I'm gonna say spread everything and apply function from next. Okay, so what is this? This is spread operator, and it actually can be used to construct new arrays. Okay, so yeah, if I'll say console log numbers, but let's add the 2000 at the end. It's easy way to construct new array. You just say let construct new array that will have in the front all entries from numbers and add 2000 at the end. So let me just check this. Yeah, so you can see this at the end. We'll just clear that out. So here I'm saying, yeah, take whatever is already in the accumulator, even if it's empty, and then at the end add the result of applying a function. Let's call this is callback function. and add at the end the result of applying the callback function to the entry from the array. So for example, I could call stuff like console log map actors, and the function will be take an actor, so each and single entry, and return string saying hello actor. Okay, and then I will get not what I expected. Actor map actors. This is good. Let's get rid of this. Oh yeah, it's already looking good. Yeah, so we have hello added in front of each and single name of our actors. So we transform one array into another one. We could also do stuff like, let's transform it from strings to numbers. Okay. Actor, sorry. Okay, and now I transform the name of the actors into an array of the length of their names. Okay. But thankfully, I don't have to implement my own map function because array already has one. So I can write just console log actors map actor length. Okay, so yeah, it's the same. So each and single array has already map defined in it. I just use the reduce function here to show you how easy it is to add some functionality to an array using reduce. Okay, and that map actually comes from reduce function. Okay, another example. What if I would like to get rid of some entries from my array based on some logic? For example, in my numbers array, I would like to only preserve the numbers that are greater than some other number, let's say 100. Okay, so I would like to get rid of those. I could write a function called filter, and it would look like this. I specify array, specify a callback function. I call array reduce because we love reduce function. Accumulator next function starting point is also empty array, and here I say function, I say callback function from next. Is it true? So does the logical expression here returns true or false? If true, then let's add next array, otherwise return ACC. So if this expression is true, add this entry to a new array and return it in the end. If not, then just let's return what we already have in accumulator. And for example, I could do console log filter, I will be numbers, and then I can write number is number greater than 100, and let's see, what number is not defined, numbers. Okay, yeah, and this way we removed all the entries that are lower than 100. So that's actually pretty nice. And again, as you can imagine, probably, we already have filter function defined in an array. So I can write numbers filter number greater than 20. Okay, still working good. Again, filter function already built into an array, but it's easy to define it using reduce. Let's just comment that out. There's also another function that's rather important, and we use it often in an array, and this is find function. So I have my actors here, and for example, I would like to find an entry that has a fox, so this part in it, and see whether this array has this entry. So I could write actors find, okay, and here we specify the logic to find the entry in an array, and for example this can be actor includes fox, and we find Michael G. Fox. Okay, so these are basically 4 functions that I use most often on the arrays. So there's no need to write imperative loops like for or while, as long as you can use map, reduce, filter, and find. Of course, there are others. There is, I believe it's called sum. Let me check. Numbers, sum, number equals how much? For example, 10. Okay, and this function will, so this function will return true or false, testing every entry in an array, and if at least one entry has this expression resolved to true, the whole expressions of sum will return true. So if I change it to like this, the array doesn't have that entry. Yeah, so basically this does my array have entry that is equal to this value? Okay, it's false, and of course for this number, no, it's this number, to return true. Okay, so yeah, but there's another one cool thing about map, filter, and reduce. They all have same interface, meaning they all return a function. So reduce, well, it can return a single entry, but if you make reduce return an array, and then you have a map that returns an array, and a filter that returns an array, you can actually chain them together, and it's really powerful because we can write something like actors are saying hello, and I can do something like this: filter actor, make sure to return only entries that have length greater than 14, 15, 13. Okay, then map these to actor saying hello actor from chain function. Okay, and let's log it. Also log long name actors are saying hello. Let me see, and it is empty. Oh yeah, because of a typo. And now I see 3 entries because only 3 actors have a name longer than 13, and they are mapped to a string. So what is happening here is first the array is being filtered. So after this operation, here we have array with 3 actors, okay, and then this array of 3 actors, because who didn't make it, Leah Thompson didn't make it, each and single entry is being immediately mapped to another value. And of course, as long as we have a function here, we can apply another function from an array. So this allows you to program a chain of an operations without declaring variables just to hold the result of one operation. Because I could do something like this, and then this, but I'm declaring this variable only to hold a result from filter. So why do it if I can just chain those together? Okay, yep. So, oh, that was wrong, but I believe that's that when it comes to some more advanced stuff you can do with functions. And I see you in the next one. Bye.